In this problem, we need to explain why b minus a all over a times b squared must be a rational number if a and b are both integers and neither of them is equal to 0. So what I'm going to do is start with the properties of integers, particularly the closure property. And what we know is, since the integers are closed under addition, subtraction, and multiplication, that tells me that we know the following things. So, first one is that b minus a must be an integer. And here's one way to write that instead of having to write it all out in words. So b minus a is an element of the set of integers, and this is because of them being closed under subtraction. How about the denominator? Well, a times b squared is also an integer because the integers are closed under multiplication. And there's one more thing we need to know. It's not just that the numerator and denominator must both be integers. We also need to know that the denominator is not equal to 0. And we can say that a times b squared is not equal to 0, since a is not equal to 0 and b is not equal to 0. Don't make that into one big a is not equal to b is not equal to 0, because we don't know if a and b are equal, and it really doesn't matter as long as neither of them are 0. And we want to say not just that we know the two numbers are non-zero, but we can also cite the zero product rule, which says that the only way to get a product of 0 is if one of your factors is equal to 0. And that's the end of that problem.